Hello, everybody, and welcome to our Engineer the Earth for a Better Future webinar. We're so excited that our future geological engineers and our future environmental engineering students are joining us today. My name is Patricia, and I'm here to welcome you to our Engineer the Earth for a Better Future webinar, where we're going to be exploring the geological and environmental engineering programs here at the University of Waterloo. Before we get started, I just want to share a couple housekeeping items, as we do want to make sure that you have an enjoyable experience with us for the next hour. So just a couple important reminders are that closed captioning is available. In terms of getting your questions answered tonight, you can submit your questions using our Q&A button that's located at the bottom of your screen. And just note that with regards to how our questions will be answered, you'll either be receiving a response through a moderated response through our chat function, or we'll get to answer your question out loud during our panel discussion, which is the second half of our evening today. And of course, at any point in this evening or in the future, if you have any questions about our programs or about admissions, you can always refer to our enginfo@uwaterloo.ca email for any specific questions that you may have. So this is definitely an email that you want to remember for the future. Before I also begin with the content of today, I just want to take a moment to do a University of Waterloo territorial acknowledgement. The University of Waterloo acknowledges that much of our work takes place on the traditional territory of the neutral Anishinaabe and Haudenosaunee peoples. Our main campus is situated on the Haldimand Tract, the land promised to the Six Nations that includes 6 miles on each side of the Grand River. Our active work towards reconciliation takes place across our campuses through research, learning, teaching, and community building, and is centralized within Waterloo's Office of Indigenous Relations. You're encouraged at some point, either throughout this event or in the upcoming hours, to visit native-land.ca to learn more about the land that you occupy. Thank you. So you're probably here tonight because you're interested or already very passionate about our geological engineering program as well, or our environmental engineering program. So I am joined by an incredible group of experts, as I'd like to refer them to. We've got myself here, the Marketing and Undergraduate Recruitment Specialist at the Faculty of Engineering of Waterloo University. We've got Dr. Jen Park. She is the Director of Geological Engineering. And we've got 3 alumni. When do we get a chance to connect with our students who graduated? Well, the great news is that it's happening today at this event. We've got Brittany. She's an alumnus from Geological Engineering. We've got Fred, an alumnus of Environmental Engineering. And Kaya is also an alumnus of the Environmental Engineering program. You'll be hearing from them all shortly. They'll be sharing some great content information with you, as well as some personal experiences, as many of them have gone through the program themselves. Just some other important notes to share with you all is that a great way for you to connect with even more environmental or geological engineering students here at Waterloo Engineering is through our EnChat service. We'll pop the link in the chat for you for easy access, but it's just a great way to set up a one-to-one meeting with our current students to learn more about the programs, about co-op, anything that you'd like to know more about. You can book as many meetings as needed, and they're typically anywhere between 30 minutes to 1 hour. And then, of course, because we have so much we want to share with you all today, a lot of you may have admissions and the application process in mind. You're welcome to ask those questions in the chat or email us, but you'll also love hearing that we've got some upcoming webinars in the new year that is 100% dedicated on admissions, applications, and some great tips from our current students as well. So mark these dates down: Tuesday, January 11th, as well as Thursday, January 13th. You don't need to attend both, as we're representing and supporting students from different backgrounds on those dates. And then, of course, a super easy way to connect with us, not just today, but also moving forward, is by connecting with us through social media. You can find us on Facebook, Twitter, Instagram, LinkedIn, and YouTube. So there's definitely a platform for everybody, and we hope you can connect with us there to once again learn more about Waterloo Engineering, as well as about some of these programs as well. So on that note, we hope you are excited and looking forward to learning all about geological engineering and environmental engineering. I'm going to pass on the virtual microphone to Dr. Jen Parks, who will give us a great overview about the geological engineering program. Thank you. Over to you, Jen.
Great, thanks, Patricia. So first of all, I just want to say I'm really excited that everyone has taken the time to join us today. It's really great to know that you are all interested in our programs. So thanks for spending your time on a Tuesday night with us. So as Patricia mentioned, I am the director of the Geological Engineering program. And when I am not directing for that program, the other thing that I do at the university is I'm an instructor and lecturer in the Earth and Environmental Sciences department. Essentially, my job is to teach students about how rocks form and why different rocks form in different places in the Earth. So once you all apply to geological engineering and once you all get accepted to geological engineering, when you are on campus in September of 2022, please pop by my office with any rocks that you might have, and I'd be more than willing to take a look at them. And if you don't have rocks, I have tons of rocks in my office that we can also take a look at. And I'm going to explain a lot about GeoEng, but first we're going to talk a little bit about what's going on and how our geological engineering program is related with our environmental engineering program. We'll get into the details in a second, but just sort of as a broad overview, you can see in the slide that we've got two different circles that are connected. So both geological engineering and environmental engineering has to do with engineering the environment that is around us. But what part of that environment differs if you're an environmental engineer or a geological engineer? And you can see the two circles are connected with each other because there's definitely a little bit of crossover between these two distinct types of engineering. So when you're dealing with geological engineering, essentially you're dealing with everything that kind of goes from the surface of the earth and then under the surface of the earth. When you're dealing with environmental engineering, essentially you're dealing with everything that's from the surface of the earth and above. So environmental engineers are going to deal with surface water, sort of like biological things, and then the atmosphere. So everything above the surface of the earth. Sort of the zone where we're connected is when it comes to how water is interacting with the earth. That's the general field of hydrogeology, and that's where we have some overlap between the two programs. And so for geological engineers, they kind of take over, deal with some hydrogeology, but then when we get into significant depths in the earth, when we're just dealing with rocks, that is all the world of geological engineers. So that's kind of a broad overview, but we can get a little bit more detailed as to what geological engineering is. It is definitely sort of a niche program, and it might be something that you haven't heard of before. So a fair question is, what is geological engineering? Essentially, what GeoEng is you're basically applying geological knowledge to where you put, design, how you build, and how you operate and maintain different structures that are on the earth. Kind of the quick way I think about it is GeoEngs deal with anything that is either built on the earth, built with the earth. So if you're building with soil or rocks, or if you're building actually in the earth itself. So maybe if you're tunneling through a mountain to put in a highway. And essentially, there's a lot of applications for geological engineering, and it is a really fastly and rapidly growing area these days. And really, it has a good connection of sort of connecting environment and stewardship for the environment with things like managing risk and creating a safer world for that we all live in. You don't need to, think too much past, the news of the past couple of weeks out in BC. They've had some pretty catastrophic rain events, and a lot of the infrastructure is getting wiped away because of all of the atmospheric river, all the rain, and really geological engineers, especially with climate change, and when we have more of these crazy climatic events, are going to play a large part in engineering a world to keep humans safe. So from there, we can kind of think a little bit, okay, what do geological engineers actually do? So as I mentioned, they design really safe infrastructure for all of us to use. So things like those highways in BC, any of the railway systems that are out there, but also they have a lot of input in building things like hydroelectric dams, which can, help to, not only generate electricity, but keep water where it's supposed to be, so it doesn't like flood out fields and things like that. Also, a really important part of geological engineering, which I haven't really touched on yet, is how they develop energy and natural resources. So I use sort of energy and natural resources in a very sort of like broad category. So resources can include things like water and groundwater, but also like hydroelectricity, and then maybe more of what you might think of the traditional terms of natural resources. So like mining, oil, and gas. However, they also have a really big part to play in things like geothermal energy, which is going to be part of the new green economy that we're all going to be living in very soon. Also, they keep us safe. So assessing geohazard risk, so whether it's earthquakes, volcanoes, or things like landslides, geological engineers can do a lot to not only assess the risk of those things, but also to build systems or design solutions to those hazards. All right, so what do you learn when you're actually a geological engineer? So geological engineering is kind of this really great sort of niche program between learning a lot of sort of like core engineering fundamentals, and then also some foundational earth science knowledge. So when you're actually in the program, you can see we've got some pictures here of people out in the field, but also in a lab room using some microscopes. So lab and field courses are really an integral part to our program. And we even have a 10-day field course where we go out and allow the students to sort of bridge all the theory that they learn in the class with sort of what's practically going on when you're out in the real world. We can be a little bit more specific about what you're actually going to learn by thinking about what courses you're going to take. And I don't want to scare anyone with all of these different names of all of these courses, but it's important to know that you are getting a really good core engineering background. So all those core engineering courses in calculus and computational methods and fluid mechanics. But then that's combined with all of those core earth science courses, because if you're building in the earth or on the earth, you really need to understand the earth and geological processes. So that's where you're going to take courses like structural geology, mineralogy, and what have you. Within our program, you can further specialize with 3 specializations. You can focus on geology, hydrogeology, or there's a soil, rock, and structures option or specialization as well. So depending on the courses you take, you can really kind of, kind of like really get into very specific areas. And then outside of the department, there's also some other options you can look into as well. Okay, so we know what geological engineers do, we know what they learn, so where do they work? So as I mentioned, a lot of geological engineering has to do with, maybe mitigating risk from geohazards or doing some sort of like resource work. So a lot of our geological engineers work with environmental and applied earth consulting companies. They also get quite a few jobs with sort of like green or geothermal energy, and this is definitely a growing field, and more of our geological engineers are getting employed in this field. We also have more sort of the traditional mining and resource exploration, but doing it in an environmentally friendly way. Also could maybe be employed in sort of different levels of government to help kind of apply environmental policy to things like mines. And then also huge opportunities to go on to further degrees once you're done your geological engineering degree. I know you're all still in high school, so I don't want to scare you with even more school after you've done your undergrad, but you can go on to many more advanced degrees from our program. All right, and I'd like to throw it over to Fred, who will talk to us about environmental engineering.
Great, thanks so much, Jen. My name is Fred, and I am currently a PhD candidate in civil engineering, but I was a graduate of environmental engineering in 2015. So right now, when I'm not doing events such as these, I'm doing a lot of research on how to improve water quality using natural and green infrastructure. So things such as wetlands and rivers and lakes, and how they are able to help improve our water quality in the landscape. All right, so to talk about the actual program, what is environmental engineering? So Historically, environmental engineering is a pretty old field that stemmed from civil engineering. And historically, it focused a lot on dealing with things such as, do we have enough water to live? And is the water quality good enough? But obviously, over the years, as we do more and more in the world with industry, agriculture, etc., it's not just the water that gets polluted. So air and soil as well are different aspects of the environment that environmental engineers take care of, help model and remediate and protect. It's also a very highly interdisciplinary field where we integrate a lot of different sciences and maths to really combine, which I'll talk about in the next couple slides. All right, so what do environmental engineers do? So like I mentioned before, one of the core elements is really dealing with how do we make sure that we have enough water for everyone to deal with, water resources, but also make sure that it's clean, that we can drink the clean water, or when we have, for example, industry or agriculture, when we release wastewater that comes from these industrial processes, that they are clean, and they can go back into the environment safely. There's also a big field in remediation. Over hundreds of years, humans have put a lot of stuff into the environment, and we might have to ask, well, where are the pollutants now, and how do we get rid of it so that we can live safely on that land? Another growing aspect of environmental engineering is how to deal with alternative energy. And also finally, much like in geological engineering, climate change is such a big aspect of our lives today. And a lot of the things that we've designed, for example, our stormwater systems or drinking water systems, they weren't designed to accommodate for climate change. So there's a lot of work that as environmental engineers that we can do to help design and develop the infrastructure that we need to protect our environment in the 21st century. All right, and then so what do environmental engineers learn in our classroom? So I really enjoyed the environmental engineering program as an undergraduate because it really touched on so many aspects of science and math, both from the theoretical side, but also from the hands-on side. So beyond the lecture, beyond the classroom, we might be learning out in the field. We might be learning how to we gather samples and measure different environmental parameters, like in the river or out in the landfill. And then we also have courses that bring all those things back into, for example, a chemistry lab or a hydraulics lab, where we can actually see, well, we measured this, what can we do about it? And then we also take that into the computer lab, where we might be able to, for example, model the fate and transport of these different contaminants. So some examples of these things that we do in our program are the final year capstone design projects that we do. These are all engineers have a design project in fourth year to really integrate all the stuff that we've learned in the past. So some example projects include, for example, river restoration to mitigate like flood impacts, designing alternative energy and water harvesting strategies for remote communities, for example, up north in the Arctic. There's also like wetland design, and also things such as like recycling wastewater sludge for actually hydrogen fuel use as a source of alternate energy. And then so our next slide, we might ask, well, what courses do we take? So there's a lot here, but it's just to show that we do have our core engineering curriculum, but as you progress through the upper years, you can really tailor your electives to something that you want to do. So for example, you might choose to specialize more in air pollution or in environmental toxicology, and you can take these courses both within our department and outside our department to really tailor your degree to something that you like. And there's 3 specific specializations that you can take just to have like a group of courses to have a well-rounded specialization. So we can specialize in energy, in hydrology, as well as pollution treatment and control. And there's also other options that you can do to tailor your degree. So where do environmental engineers work in? So they're just like geological engineering, there's a lot of places that we might end up in. For example, in consulting firms, that's where you do a lot of consulting with different industries and perhaps developers to really assess like the environment, what's going on there, and how can you treat them, like treat the problems there. You might be working in the government, you might be looking at green tech, public health, or like myself right now, might be continuing in future studies with a graduate degree. All right, so I think I'll pass it on back to Jen to talk a little bit more specific about our programs combined.
Right on, thanks, Fred. So why should you pick geological or environmental engineering at Waterloo? Well, first of all, a really great thing about both of these programs is that we have small class sizes. And particularly for me, also because I'm a GeoEng person, we usually a big class for us would be about 30 students. But even with the environmental cohort, it's a little bit bigger because it is relatively small compared to other programs. We have a much more sort of like community feel in the program as a whole. So I think there's a lot more community building between, the people who teach in the programs, the students taking the courses, and also people who help to administer the programs. And, I think a good sign of this is that, we've got all of these great alumnus who are giving up their time on a Tuesday evening to help talk about how great these programs are. Another pro is that you can just go into either of these programs right from high school. So this is different than other universities. Some other universities, you do a common first year. So you're with like the mechanicals and the chemical engineers and the civils and a bunch of other sorts, and then you differentiate after that. We start right away in the program that you want to be in. And then you start doing co-op placements as soon as you're done your first academic term. So that means you go to school for 4 months and then you get a job. And that's something that's not possible if you're doing that sort of like common first year generally. Also, as Fred mentioned, with EnviroEng, there's a lot of ways you can like specialize and focus. Same thing with geological engineering. There's a lot of cross-discipline courses that you can take. So the GeoEngs, quite often it's with the earth science department, but also, the environmental engineers, you can take courses in like, environmental, planning and toxicology and things like that. So you just don't get sort of like a very focused traditional engineering degree based on the courses that you're taking. You get to learn a lot of different things. Also have some award winning instructors, which I think Fred is maybe going to touch on a little bit later. But people who are at Waterloo, once you apply and you're accepted to our programs, we want to keep you in as students, and we do our best to deliver courses the best way we can. And quite often our instructors are winning national awards. Also, we really focus on this idea that engineers are designing solutions to problems. And we start right out with that concept of design in first year, where there are design days that students, you sort of take off from your normal courses, you're given a problem and you have to design a solution. And then that scales up to the fourth year capstone programs or projects that Fred was talking about, which is kind of like, your fourth year thesis, where you design a solution to a problem. Also, lots of lab and field-based learning, as Fred and I have mentioned. But also, I would like to focus on what Fred said is that, we go out into the field or we go to the lab and we get data, but then there's lots of chances to use really big data sets in sort of trying to solve and design solutions to environmental and geological engineering problems. So you get some lab work. You can be in the field if you want, but if you're not a field person or a lab person, there's still lots of opportunity to use big data and things like machine learning to solve problems in both geological and environmental engineering. And of course, we are completely an accredited program, so you get the designation as PEng after you work for a couple of years in the environmental and geological engineering program. And one extra bonus for the geological engineers is if you're just a little bit careful about how you pick some electives at some point, you can also qualify to be a PGeo or a professional geoscientist. So you can actually be a professional in 2 different organizations. All right, and once again, just to kind of give you an idea of kind of like the idea that these are separate but connected programs, in the first 4 months of your school and the second 4 months of school, so your 1A and your 1B term, the courses that you will take as geological and environmental engineers is actually the same. And then once you go on to second year, that's really when you start to differentiate from these programs from themselves. The geological engineers, that's when you're focusing on sort of more geotechnical courses and also core earth science courses. Environmental engineers, that's when you're going to focus on that sort of environmental chemistry, biology, air quality courses. There are a couple of common courses where you'll meet up again with the geo and enviro enges in upper years. And you do have the ability to pick some electives as well. So not every course is, you're told to take certain courses. Depending on geo eng or enviro eng, you do get some technical electives that you get to pick. So if you're a geological engineer and you decide that groundwater is the thing that you want to do, you can take more courses in groundwater. And then you'll also take a few things called complementary studies courses, which are kind of more breadth courses where you can take, a philosophy course or, a psychology course or what have you. So you're not just getting that technical degree. And I'll pass it back to Fred for these next few slides.
Cool. So as Jen mentioned, a lot of our work as engineers that we want to learn the theory, but we also really want to know how do we use it in practice. So a lot of our courses integrate these different hands-on activities or projects to really test out what we learn. So for example, in our fluid mechanics courses, you might be building boats to learn about hydrostatics, or we built like pipe networks to look at how water flows through different pipe networks. Also, a very cool part of the engineering curriculum now is what we call the design days, where you take a couple of days off from normal classes. It would be optional, but you basically go into our big design space in Engineering 7. And you work as teams to try to solve different design problems. So as civil enviro geos, some recent design day problems include designing and testing of dams and landfills. And those are the pictures you see over there on the right and on the bottom. There's also a lot of different design teams at our faculty where we might be working with people from across the different departments. For example, Habitat for Humanity, you might be designing different structures for them, a concrete canoe, which you might be surprised that canoes can be made of concrete and can float as well as Engineers Without Borders. And so these are things that happen sort of like within our faculty. And obviously we have our 6 different co-op terms where we can have more practice and learning, applying what we do with what we learn. And then on our next slide, we have some of our key people in our undergraduate program. A lot of our instructors here, they're really dedicated to teaching and making sure that you succeed in our undergraduate program. For example, right away in first year, we have Bob McKillop. He usually teaches our core concepts course of engineering, environmental and geological engineering. Not only will you learn things specific to our program, in this course, you'll be working a lot with, for example, technical writing, like writing memos for industry, or writing a resume to help you find your first job after your first term, as well as just different skills and learning strategies to help you set up for success in the future terms. So we have a really cool team that really that doesn't just teach you the technical stuff, but really helps you try to succeed. And then one last thing is that in addition to the staff and faculty, there are a lot of student societies at Waterloo there to support you as well. So within our department, we have the Civil Environmental Architectural and Geological Engineering Society. So they run a lot of department-specific events to try to support the activities for our students. So for example, they might have industry nights where they invite people from outside the department to connect and learn about what you can do with your degree afterwards. They might also set up technical visits. So for example, they might partner with the local wastewater treatment plant or the landfill, and you'll have a tour of there, and you can meet up and see what they do there. We also have the Engineering Society, which is for all engineers, not including or in above to the geological engineers, and they run a whole slew of events as well. So anything from resume critiques to wellness events such as like de-stress with puppies, as well as many other fun events that I think our student alumni can talk about. I think I'll pass it on to them actually, since we'd love to hear more about their experiences during their programs.
Perfect. Thank you so much to both Fred and Jen for some incredible content about both programs. I think myself now I'm ready to maybe consider applying to both geological and environmental engineering. So thank you so much for that. As Fred just shared, we've got 2 more special guests to share a little bit more about their experiences before we wrap up the evening, dedicated to a panel discussion where we get to answer your questions live. So on that note, let's bring up Brittany to the stage to share her experiences, as she didn't graduate from this program too long ago. So over to you, Brittany.
Thank you, Patricia. So I'm Brittany. I graduated from the Geological Engineering program at Waterloo in 2019. Currently, I'm a graduate student at the University of California, Berkeley, and I'm studying geosystems engineering. That's just another term for geological engineering. My PhD is about developing better levee inspection practices through non-invasive imaging techniques, as well as machine learning, to make these systems more resilient to hazards that threaten them, such as hurricanes and earthquakes. So for some of my co-ops, the first one was with the MTO in St. Catharines. I was doing a literature review on the amount of salt and sand usage used on the roads in the winter. The second one was a geotechnical engineering consulting company called SPL, which is located in Toronto. It's now part of WSP Canada, and I did a lot of different things at this job, but mainly I was doing rock core logging. My third co-op was with Englobe in Kitchener, and I was doing compaction inspection of asphalt and soil for construction. My fourth one was with the United States Geological Survey in California. I was looking at seeing if the rate of earthquakes in Kansas and Oklahoma increased or decreased after large seismic events. Then I worked for a seismic geophysical company in Connecticut. And then lastly, my final co-op was in the Canary Islands, working with Invulcan, which is the local volcanology institute, and I was seismically monitoring volcanoes. And one of those volcanoes is now currently erupting and has been on the news for a couple months now. So because I'm a graduate student and I don't plan on being one forever, my career aspirations is to actually become a geological engineering professor. Through my time as an undergrad and as a graduate student, I've realized how important geological engineering is to modern day society. And I think having well-trained engineers is going to be really important, especially with climate change coming up. So I want to help train the next generation of geoengineers. And then just a top tip about co-op jobs and getting one in general. Be proactive about it. These opportunities aren't just going to come to you. You're going to have to put some effort in to find the really good ones and apply to them. My really cool co-op jobs, I had to take the initiative to look for these jobs. And those are really the jobs and opportunities that are going to make a difference. And they're going to make you stand out when it comes to graduating. So there's a lot that I love about geological engineering, and I can talk about it for a long time, but I'm not going to, and I picked 3 of my favorite things about the program. So the first, I know it's already been said, but the small class size. So I actually started off in a different program that had 100 plus people, and then I switched to GeoEng, and there were 19 people in my graduating class. And I can tell you it makes a huge difference. With only 20 people or so, it's really more of a community, and you get to know everybody in the class, you get to work with each other, everybody helps each other, and you really get to know your professors, and you get to know them much better than if it was 100 people in the class. And it makes a huge difference being on good terms with professors. Also, it has been talked about, but the program is very hands-on. And for a field where you're always using rocks and you're looking at rocks and soil, it's very important to be able to pick them up, look at them, be able to understand what they're doing. And the courses at Waterloo really allow you to do that through labs, field demos, and field trips. So a lot of the courses you're gonna take have labs, earth science and engineering both, and it's really a great way to learn about what you're gonna do. And a lot of that, what you learn in your labs and your field trips, you're gonna apply them in industry. They're not just gonna teach you it for the sake of it. You actually use a lot of that information. And then one of the other really cool things about geological engineering is that we take classes both in earth science and engineering. And when I was an undergrad, I did the math, and it's about 60% engineering courses and about 40% earth science courses. And this is really important in industry because a lot of the projects that you're going to be on as a geological engineer, you're going to need an engineer and you're going to need a geologist. There's no way you can separate the two. And a lot of the time, the terminology is very different from each other. So as a geological engineer, you learn the terminology for both, and you become the bridge between geology and engineering, and you make those projects more successful. And also because you take a lot of earth science classes, you do get that you do get to be dual licensed. So you can be a professional engineer as well as a professional geoscientist. And that's something very unique to geological engineering that a lot of the other engineering programs don't have the opportunity for. And so just passing it on now to Kaya.
Hi everyone, so my name is Kaya and I recently graduated from the environmental engineering program at Waterloo just this past June. So I've only been out of school for a couple months, but I'm currently working at an engineering company in Guelph called Van Harten Surveying and Engineering. So my co-op experiences at Waterloo, I've had a variety of different roles at different companies. In my first term, I worked at 3 different companies actually in what was called the BETS program, which stands for Bridging Entrepreneurs to Students. So essentially, the university hired around 30 students that were first-year engineers to work for different startup companies that were funded by Velocity, which is a startup incubator at Waterloo. And through that, I got the opportunity to work in a startup environment at 3 completely different companies where I did research and lab work in a chemistry environment for my time at SunCare. I got to do some mechanical work at Borealis Wind, and I did web design, which was completely out of my comfort zone at Deep Subconscious. So that was a really great start to my co-op, which enabled me to get a lot of good experience on my resume to help me get jobs in the future. So the second co-op job that I had, was at the formerly Ministry of Environment and Climate Change, which is now the Ministry of Environment and Conservation and Parks. And I got the opportunity to work in their air quality department, where I learned a lot about air quality standards for the province of Ontario. And I was able to read through reports and technical standards for air pollution and contaminant thresholds. And I got to see a bit of how air modeling works using different software. And in my third term, I worked as a junior environmental scientist and an engineer at the same time for a company in the Bahamas, which is where I'm from. So it was really cool to be able to do a co-op back in my home country at a coastal engineering firm where I got to learn so much about field work, and I did a lot of AutoCAD, and I learned a lot about design and environmental report writing and environmental compliance. And in my fourth co-op term, I worked as an engineering assistant at York Region, where it was kind of more of a civil experience where I learned about transportation asset management, how the town upkeeps their transportation assets like roads, bridges, and culverts, things like that. And my final co-op term, I worked at PCL Construction as a renewable energy student, where I got to design solar farm layouts, which is really cool. It was really challenging, but it really helped me learn a lot about energy and how different clients require their solar farms to be set up, and that really kind of piqued my interest in that area. And currently I'm working as a junior engineer and a CAD technician at Van Harten Surveying. And what I'm doing is kind of doing engineering design drawings for lot development and sewage design, and I'm currently working under a professional engineer learning about the sewage design aspect of things and lot development and grading and how all of that comes together. And for my top tip for co-op, I would say be persistent, don't give up, because it's pretty easy to not see the interviews coming in your first term and think that this isn't meant for you, or that it's not going to happen because you're not seeing any success. But realistically, it's difficult for a lot of people to get a job in their first term because you're fresh out of high school, you don't have much experience. So don't give up, don't let that deter you, because the opportunities will come and it will only get easier from there. So what I love about environmental engineering, a lot of similarities to what Jen and Brittany said already, but the variety of my co-op experiences is definitely a big standout because it enabled me to learn not only what I like, but what I don't like, different work environments. Like I mentioned earlier, I was able to work in a startup environment, a government environment, and consulting. So having experience in all three of those areas really helped kind of allow me to hone my direction for where I want my career to go in the future. And like Brittany mentioned, the cohort size was a very important aspect because it was kind of a family environment that is something that you just can't get in other programs. And the professors, definitely, I had some standout professors that made my experience 10 times better. Their passion for the subject that they were teaching kind of passed on to me and helped me to recognize what I wanted to specialize in my fourth year, and helped me to choose my technical electives just based on their great teaching of the subject. And another thing in common with geological engineering, the labs, I really love the hands-on experience that environmental engineering gave me in terms of being able to work outdoors and in chemistry labs and hydrogeology labs, being able to get that experience where I can go out, take samples from outside, measurements, and then take them back to the lab and run the experiments on the samples that I collected was kind of very full circle, which I enjoyed. And similarly, I got that full circle experience from the knowledge that I gained from my theoretical classes being applicable to the lab components. So there was kind of a give and take between the labs and the theory, which really helped me to understand the content much more and really get a full experience.
Perfect. Thank you so much to both Brittany and Kaya for sharing some of their personal student experiences. We're not just done yet from hearing their experiences, as we're going to move on to the panel discussion portion of the event. Which means that before we officially transition, I just want to point out, you probably got some questions about our programs, about Waterloo Engineering as a whole, about admissions, whatever the case, just a quick reminders. You can connect with our current students through our NCHATS initiative. You can email us through enginfo@uwaterloo.ca. We've also got an opportunity for you to connect with us through live online chat. So you can take a quick photo if needed, but if not, we'll make sure we send out this information to you after tonight's event. So on that note, thank you for tuning in. I'm going to stop sharing my screen and bring forward our experts back to the stage here so that we can just dive in and learn more about our programs, share more about our experiences, and go from there as well. So we'll give everybody a couple seconds for our panelists to join me here on the virtual stage. Amazing work, everybody, sharing your passions about geological engineering, environmental engineering. We're going to do a quick little thing just to make sure that our students who are joining us today, students, parents, counselors, anybody's welcome to this event, just has a quick understanding of kind of everyone's background. Actually, I will do that honors because so that we can just jump in right into some questions. So just a quick reminder to the group, I'm going to go through my order of the screens here. We've got Fred. He's an alumnus of the Environmental Engineering program and currently doing his PhD here at the University of Waterloo. We've got Brittany, who's a geological engineering alumnus who didn't graduate long ago and is currently also doing her PhD, but not on our campus, but another incredible university out in the States. We've got Kaya, who's an environmental engineering alumnus. She is the most recent graduate and graduated just a couple months ago, and she's currently working in Guelph, Ontario. And then last but not least, we've got Jen here, who's a director of geological engineering and a professor and lecturer in the program. So we've got a great group, and I hope we're ready to dive in. So my first question is going to go actually to Jen. And the question is a little bit more about, because we talk so much about the difference with that there's in classroom experiences and also outside the classroom experiences, for maybe both of those programs, can you kind of summarize how much of the hands-on work is divided between indoor labs versus actual outdoor field work?
So that's a great question, and I feel like I may not be able to give you a percent, but depending on what course you're taking, and especially if it's not the winter term, there's definitely a possibility that you're going to be getting outside and doing things like taking water samples or what have you. So within the classes, a lot of them have these integrated lab components, and for some of them, you will be actually going outside. We do have our 10-day field course, which is a whole course, which is outside. Actually, I feel like the students might have or the alumnus might have a better idea of like what the percent of kind of like in the field versus in the lab might be. Does anyone want to help me out with that one?
For geo, at least, I know hydrogeology's lab is mostly outside. I know I did 4 field trips while at Waterloo. There was a 2-day mineralogy trip, the 10-day geological mapping trip. And then also in 3rd year, we did a day trip to Hamilton to look at a river restoration project, as well as 1 day canoeing on the Grand River. And then a lot of the earth science courses have hands-on labs, and then those are in the actual labs. And then a lot of the specialized engineering courses also have labs.
Amazing. No, that's a perfect background. Exactly. It's definitely hard to pinpoint to what the percentage is, but I think it's nice to know that students are going to have in the classroom experiences doing hands-on work, and also some great trips to look forward to outside as well, which seem to be everyone's one of their favorite aspects of the programs, which is amazing to hear. Going back to the students here, something that we want to share with our audience is mostly our students are currently in high school, which means we want you to do a little bit, go back a couple years and think back to your high school selves. What was that inspiration, that motivation for you to choose geological or environmental engineering? So we'll start with Fred on that one. What made you choose environmental engineering, thinking back to your high school self?
Yeah, when I was applying, I was looking at a lot of engineering programs. They all looked really attractive to me because they kind of married both like math and science, but in a way that was applied, that we can try to like design solutions that like change the world basically. So that really drew me to engineering, and to Waterloo specifically was that they had a really cool specific environmental engineering program, which not a lot of schools have. And that integrated a lot of co-op experience as well. So I applied to like both science and engineering programs, but I enjoyed, or what drew me to engineering specifically was this application and being able to like design solutions to make some change.
Amazing, and we'll throw in our pun there, but to make the earth a better place, correct? So amazing. Thank you so much, Fred. How about yourself, Kaya?
Yeah, it was kind of similar. Growing up, I always loved math and science, so I kind of always wanted to do something in the STEM field. And I think around 9th or 10th grade, I decided that I wanted to do mechanical engineering. But then in grade 12, my dad's an aviation engineer, so I think he wanted to make sure I wasn't just trying to like follow in his footsteps. So he asked like why I wanted to be a mechanical engineer. I couldn't really give him a reason. I didn't really have a reason because it's kind of like the typical program you think of. So I kind of did some more research, and I always loved the environment and environmental science. And I didn't really know that a program called environmental engineering existed. So I did some more research and then found this program, and like Fred said, it kind of married the two disciplines perfectly, and I thought that was really cool.
Wonderful. And over to you, Brittany.
I might not be the best person to talk about this because I started off in a different program actually. And it wasn't until my first year that I realized I was in the wrong program and I wasn't liking it. And then I took the first year Earth Engineering course and I absolutely loved it. And after talking to different professors and looking into it a little bit more, because I didn't know it existed until I got to Waterloo. After like doing a little bit more research, I realized that it was actually very interesting and I thought it was cool. So I ended up making the switch and I never regretted it.
Wonderful. And, you know, it's nice to hear different perspectives of how students came to, you know, fall or find the program for them. So it's nice to hear from the different perspectives that each of you have had. Jen, I'm going to go over to you to the next question. This is from one of our audience members. Are there situations where environmental and geological engineers work together in projects? And of course, the students could chime in as well based on your experiences.
Yeah, so is that more like in school or like in the real world?
How about we do a little bit of both?
Okay, so definitely a lot of the courses that you'll take in the engineering side are the Enviro and the Geo classes actually together. And in that case, you know, if you're doing something that requires a project, I think it's fairly common to have some cross-pollination between the groups. I'll let the students correct that in a second if I'm wrong. But in the real world, I think there's a ton of crossover between environmental engineering and geological engineering. I think especially when you're kind of in that world where you're just a little bit below the surface of the earth or just a little bit above, especially when you're dealing with things like groundwater and surface water interaction. This is a huge field and it's very important for, you know, environmental consulting companies and, you know, monitoring things like water quality and things like that. You know, water just doesn't stay on the surface of the earth. It eventually goes into the earth. So there's a lot of collaboration between the two types of engineering, especially at that kind of that place in the world where things meet.
Perfect. Perfect. So speaking on some of this real world environment situations that we're thinking about, this is for our students and our, I guess our alumni is the better term to be using. But have any of you had any experiences maybe working directly with industries or communities? One of the questions that we got from an audience member is if students get the opportunity to work hands-on with real life projects, and again, in connection to industry partners or engaging directly in community spaces. So I'll leave that as an open-ended question if anybody wants to jump up and share maybe some of their own experiences.
Maybe I'll pitch in to start off with. So one of the most direct ways is through co-op terms. That's where we get so much of our experience, like interacting beyond just the university. So for example, one of my co-op terms, I was an engineering specialist with the community of Stouffville, where I grew up actually. And it was a really cool way to interact with like developers as well as the community, like trying to solve like different environmental problems and get that through the town. In the past, one of the instructors developed a really cool class project to help design a playground for a local community to help apply our basic like physics concepts like in statics and dynamics to so they, as a class project, they designed that, and I think they built that soon afterwards. So that's some ways to interact with the community. I don't know if other people here can.
Yeah, like kind of similar to what you said, co-op really gives you a lot of opportunities to do that. I remember on my third co-op term, when I was working back in the Bahamas, I actually like got the opportunity to work on this really big project that involved people from 6 or 7 different countries. And being able to like coordinate something like that as a student was something that I never thought would be possible. But working on that kind of showed me the reach that you can have even just through a co-op term. And then also through your capstone design project, I think a lot of times you have to do like community research depending on what it is you're working on. For example, I did a lot of research on Iqaluit and the communities there, because that's kind of where my capstone project was based. So there's a lot of different outreach and research.
Thank you, Kia and Kaya. Sorry, Kaya and Fred. Kaya, we lost you a little bit at the end there, but I think I got most of the responses that you were sharing. And I think it's great what I'm hearing from both Fred and Kaya is that one really incredible way to directly connect with industries and with community partners is through our co-op experiences. And for those who may have missed it, here at Waterloo Engineering, you can do 6 terms in total, which is quite incredible that you'll be graduating with 2 years of experience by the time that you graduate. It's a very special component of the Waterloo engineering experience. And Kaya, you're also sharing as well in some of your personal experiences that another great way to do this is through your final year, 4th year design project, also known as the capstone. And you were sharing that you've gotten to do some research in Iqaluit, which seems pretty awesome. So fantastic, fantastic. I'm going to jump back to the students here because our audience, a couple of our audience members are concerned, not concerned, but when they think of engineering, they think of coding and programming and things like that. So was that an expectation that you needed to have that background coming in? I know, Kaya, you were sharing one of your first co-op experiences. So Brittany or Kaya, maybe I'll bring this question to you. Brittany, go for it. Tell us more about the coding programming and what that expectation is.
So coming into Waterloo, I had no coding experience whatsoever. I never touched coding in my life. Honestly, it kind of scared me a little bit. But you do take a coding class in your first year, at least you did, and they really go through the basics, and it's very helpful. And now I'm writing Python and MATLAB every day. I use it every day, all day long, and I have no issues. So you don't need to know it coming in. You'll learn it, and you'll get really, really good at it.
That's amazing. We'll quickly open it up to either Fred or Kaya if you've got anything to add to that, or if Brittany give it a good summary.
Actually, just to add to that, in case anyone's like really scared, you do get a good idea of the basics of MATLAB and Python and stuff like that if you end up working in a field that requires that. But for people that maybe that isn't your goal, it's not necessarily like I'd say the typical path that most environmental engineers at least go down. It's definitely a useful tool to have for like analyzing data, but I'd say you don't have to like be a professional coder by any means.
Yeah. Awesome. I think the audience appreciates hearing again both perspectives of how Brittany is using it on a day-to-day basis in her current work, and that Kaya is sharing that it's not an expectation to be a professional coder by the end of it. So fantastic. So great. So next question is going to Fred and Kaya, both from an environmental engineering perspective. One of our audience members wanted to know a little bit more about what are the main differences between a degree in environmental science and environmental engineering. And I think that's a very fair question to be putting out to the table.
Yeah, so I sort of touched on that before. So as an environmental engineer, you have lots of opportunity to take courses in the sciences, so whether it's earth science, biology, physics, etc. But we take them more as electives, or a couple of them are within a core curriculum. So we do get that exposure. But our curriculum is supplemented by all these other engineering courses where we can learn how to use these fundamental science concepts to, say, for example, design a wastewater treatment plant, or look at how to remediate the soil, et cetera, like things like that. Whereas I think in environmental science, they have a much broader science background, but they don't have the same supplement in engineering that we have.
Perfect, perfect. No, that's a fantastic overview here. So I definitely appreciate that. I know panelists, we could continue chatting for hours and hours and hours because there's so much to cover about both programs. We definitely hope we did a great job tonight, sharing a little bit more about what the programs entail, but also some of the special features that exist here with these programs in the setting of Waterloo Engineering. For one of our final questions, I'm going to have each one of you share a couple final words here. What advice, what words of wisdom, anything, it could be on to our alumni now, but maybe you have an admission tip to pass along to our students. Jen, maybe you've got a perspective to share from a faculty member of something that students could look forward to in the first year. So in any regards, if it's you want to tap on one more co-op experience that you've had and you want to inspire the group with one more experience. So I'll leave this open-ended, but I think I want to dedicate a couple more minutes to just get each one of you to share some final words with our prospective students. And how do we continuously share with them that these are incredible programs that they should be considering, hopefully applying to this year if they're in grade 12, or if not, maybe passing on the greatness of these programs to other students in case you may be a teacher or guidance counselor who joined it today. So why don't we start with Jen. Jen, if you want to start us off with some final words of wisdom from yourself.
So I want to kind of touch on something that Brittany said. So, you know, it is okay to make the wrong sort of like decision when you apply to universities. Once you're at a university, there is a lot of chance to sort of like transfer around in programs. And especially, it's great that you are all here tonight and you're allowing us to explain what geological and environmental engineering is. But maybe there's some kind of other engineering that you don't know about, and you'll find out about it when you come to Waterloo. Not that I want you to, you know, register in other programs. I want you all to be geological engineers, but it's okay. It's not the end of the world if you apply to a program, you know, maybe you apply to environmental and then you're like, oh, really, I should be in geo, or maybe even like, you know, oh, I applied to environmental engineering, maybe I should be in environmental science. I know there's a ton of pressure when you're coming out of high school to decide what you want to do for the rest of your life. When you're in grade 12, that's a hard thing to know. So I just want you to know there's lots of chances to kind of like make corrections in your decisions. We are more than happy to share whatever we can about these programs with you to help you make that decision. But in the end, there's lots of chances to get into what you're really supposed to be into, and you'll find your way no matter what it is.
Can I say something on that? So one of the great things about Waterloo is also the co-op program, because it allows you to test different jobs and different opportunities. So let's say you're in geological engineering, but you don't know what type you want to do, right? Because you can do a lot in geological engineering, right? You can be a geotechnical engineer. You can do mining, you can do oil and gas, you can do tunneling, and through co-op, you can figure out what you want to do. For me, I changed my mind like 5 times before I finally made a decision, but co-op really allows you to figure this out, especially if you take the opportunities that co-op gives you.
Amazing. Thank you both, Brittany and Jen. Fred and Kaya, for some final words as well.
Yeah, and maybe, sorry to jump on again, but also in addition to co-op, both our programs, Enviro and Geo, gives our students a really broad overview of everything that the field can be. Going into environmental engineering, I thought it was very narrow and just like basically looking at where does water go. But over like many courses, I started to really find what I was passionate about. Like I enjoyed doing field work, but I didn't know, but I found out that I really enjoyed modeling and coding, and we had courses for that, and we could specialize in that. And I had other friends who enjoyed air pollution more, and they found out through different courses as well. So it's a really good place to, if you think you want to look at environmental and geological stuff, our programs do give a really broad overview and allows you to specialize once you find that passion as well.
Perfect. And the last microphone goes to you there, Kaya.
Yeah, well, firstly, just to add on to what everyone has been saying, I agree completely with specializing in what you're more interested in as you're coming close to graduation. I realized I was really interested in energy, like closer to my fourth year, because of different courses that I took in second and third year and co-op programs. So I kind of tailored my fourth year electives to the energy specialization. And I took courses in the mechanical engineering department. So you have the option to kind of branch out in that way. But also as an international student and as a student in general, there's a lot of pressure on you as a first year. And I feel like it can be really tempting to give up in challenging circumstances. But I want to encourage everyone not to do that because it's so worth it in the end. Like, I appreciate the good and the challenging experiences that I have at Waterloo, and I would not trade them for anything because they've really helped me grow my critical thinking. And that's something that's really important to have as an engineer. It's something you'll use for the rest of your career. So I'd say really go into it with an open mind and be willing to learn.
Amazing. The panelists are all giving some passionate head nods here. So I think that's a fantastic note to wrap today's webinar dedicated to exploring more about our geological and environmental engineering program at the University of Waterloo. So thank you so much to our experts, our panelists, our alumni, our directors who've joined us. But of course, a really big thank you to our viewers for tuning in to explore more about these programs. We do hope to welcome you to our community in September of this year for our current applicants, and for those not in the application stages, we hope to join you in future years as well. Thank you again. This recording will be available on YouTube. We'll be sending you an email shortly so that you can rewatch this webinar 15 times on repeat, because we know that's what you'll be doing after this. But hopefully we have shared lots of excitement and great knowledge about these two programs. And as you all know, these are, in the world that we're living today with climate change being such a pressing topic, we need more environmental and geological engineers. And we can't wait to have you both, not both, but students who are interested in both of these programs, making that impact on the earth today, on the earth tomorrow. So you are needed. This is a very important and desired program. So thank you again. Have a lovely evening, and we cannot wait to connect with you all very soon. On that note, we will awkwardly wave goodbye, and we hope to chat with each of you very soon. Thanks again, everybody.